In this problem, we are asked to calculate the sum of prime numbers between the number 60 and 70. Anything greater than 60 and less than 70. Before I get into the problem itself, let's look at what a prime number is. A prime number is divisible by 1 and itself only. For example, number 2, it only has two factors, 1 and 2 itself. Same thing with number 3. Same thing with number 5, and same thing with number 7, and so on. So if there's a number that's only divisible by itself and 1, that's a prime number. And just a quick tidbit right here for you guys, something to just remember, is that 2 is the only even prime number out there. There's no other even prime number except 2. Alright, so back to the problem. So I've listed all the numbers between 60 and 70 out here, just to save some time. So let's go through this list and quickly knock out the ones that we know are divisible. So let's start with number 2, because everything is divisible here by 1, we know that. But we want to figure out if any of these numbers have any other factors besides 1 in itself. So let's start with number 2. We know that 2 will divide 62 because it's an even number. So this is out of the list of prime numbers. So is 64, so is 66, so is 68. All these are divisible by number 2 because they're even. We know that 3 will divide a number that, if you add up the digits of that number, is divisible by 3. For example, 63, it has 2 digits. So if I add 6 plus 3, we get 9. We know 9 is divisible by number 3. So this is also out of the list of prime numbers. 65, that adds up to 11, so that's not divisible by 3. 6 and 7, that's 13. 6 and 9, 15, divisible by 3. So this is also out of the list. We know that 5 will divide a number, sorry about that. 5 will divide a number, any number that has a unit that equals 5 or 0. So this is also out of the list of prime numbers. I think here in this list, only 61 and 67 are prime. So let's add them up. 61 and 67, we get 128. So the answer in this case is choice B.